Oh, no, gas, just gas for. We like this one, right? Cause the one was also. But then it was, like, bromine. Reacted with water, right? But it was, it's strong, so it wouldn't count for it, and right? Liver, yeah, that's strong enough, so it doesn't. Same things like that, very. But if it was weak, or like F minus, right? Yeah, would it still affect it? Would you react with the shit, right? Yeah. Yeah, like calcium. Or chloride, yeah.
Is the common ion effect like
I
a part of like
I don't think.
the other principle, the
Either.
I'm not saying.
Chandelier.
Yeah,
Yeah.
it's just like a part of that, and that is like, so like, we learned about it, but I can see it like
Or
named in anything. Is that for like,
Calcium and BR are both react.
is the common ion effect only for like,
One was react.
like salt ions,
Reacts with
like, or is it also for like acids and bases as well?
It can also be for that too.
Awesome, okay,
Yeah.
it's just the idea.
So like if you, let's say if you add,
Like this
part
one.
of the reason why if you add a conjugate
It
base,
was.
like you increase the pH, right? So like it's one way to
Was- Adding.
right? If you write it as reaction,
Yeah. Three of,
if that's adding conjugate.
So that would react,
base,
yeah,
it's
the-
still
extra.
decrease the hydrogen content.
So it's a weak base, it would react with the H plus and it would shift in. Well, that's interesting, that's how you.
Like if I'm adding like.
I think of it, I think of it as adding it to here, so just shift.
Well, yeah,
right?
hydrogen was just added to
But
the
it
pH.
doesn't make sense.
So if I'm doing
Both ways work.
NaA, right? It's going to increase this amount, causing the reaction to shift over.
Meaning that there's more, wait, so here's the example, so if this increases, right?
Let's say like.
Then like, I was just like, so like beginner, like it's like beginner.
anyways.
But if that increases and there's more
CO2, I don't know.
to react with that,
Mhm.
and that's why that gets used up.
Mhm.
So there's less hydronium,
Yeah,
meaning
which
that
increases. the pH.
increases the pH, because obviously acid at a lower pH.
Yeah.
Okay.
Not much.
And this was this. Fancy.
Oh, that's what they said, but when you want to-
Yeah.
What?
Yeah, thank you.
All right,
Closer.
hi guys. Take a nice deep breath in. And out. No, we had deep breaths, all right?
I can't do
You guys are
that.
gonna need to know this and a lot more stuff for the MCAT, so like. Every time, yeah, no, one thing at a time, but you guys wanna make sure at some point you feel a little bit confident with your like testing skills. You don't wanna go into the MCAT thinking you're not confident. And you don't wanna go into this exam thinking you're not confident. You guys have spent 2 months or so, like approximately like a month and a half maybe, going over a lot of these different things in class. And I'm sure the last week you guys have been going through a lot, going through a lot of these things. So you guys have had a lot of time to study, a lot of time to like go over things, and like that hard work isn't like there's gonna be some level of fruit that comes out of it. You guys have the tools for success for this exam. All right, so when you guys are taking the exam, take a nice deep breath in and out before you start it, and just concentrate. All right. Yeah. So we're gonna go over like. I'll give you guys some time to maybe like do some of this, like the practice exam from this is the exam from last year. So you guys can have time to like do it. I emailed you guys this. And there's an answer key. I sent the revised version this morning. So you guys can check that out as well. But we can go over it and go over some of the questions. So just like a little bit of like information about the exam from last year. There's 33 questions, right? So there's 33 questions for you guys to do, like, I think like it's like 80 minutes or so, right? To do 33 questions. Okay, so my like strong advice would be to try to get the tests done with time to spare so you can check over your work. Because for me, like I would catch a lot of my mistakes by checking over my work after the fact. So I would recommend trying to go, like, try to do some of these questions a little bit faster, especially if you know how to do these questions. All right, you guys have done a lot of these same kind of questions over and over again, but be confident, be fast, be accurate. You guys got this. Okay? All right, that's my little TED talk, okay? Believe in you guys, all right? So I'll give you guys some time to like do this first page or do the whole thing and then we can go over it. And I'll just like walk around and help you guys out. Okay? Okay. We'll like come back together around like maybe 4 o'clock or so, 4:15. I'll be here. What do you want to about? I don't know. Don't say that. Yeah, what are you talking about? Probably on YouTube. Have you, did you watch my YouTube video? That's the basic? No. And no, like, I know the YouTube video where I go over the questions. Oh, okay. Yeah, if you want to check it out. Yeah, that was a problem. But who wasn't supposed to be like, bottom? No. Yeah, we'll just. We'll check it. Yeah, technically, do you want to put some consolidate acid on base? The answer is consolidate base. Acid. Like, yeah, like. Yeah, the answer is-
You sent us an email with that?
For the video? Yeah.
That was very helpful.
What?
Yeah.
How long was it?
But I go into like one question,
Yeah, I'll probably watch.
and like
it.
there's timestamps, so like you can.
It was very like big picture.
Mhm.
Like,
Maybe that's what I'm using.
Yeah, it goes over like all the math questions and like I talk about concepts and so like. Mhm. Yeah. Video, so. You can save them and then. Yeah, no problem. Yeah, so that goes over module 5, basically, and so. Module 6, obviously, module 6 isn't that bad, right? It's only like 24 slides.
Yeah, it's pretty short in content.
Yeah.
That's that similar stuff. I know.
Yeah, it's like it's-
you know, like. Wait, for first start, acid, you could just like, if you're finding pH, you could just do negative log of whatever the concentration is.
Mhm.
Cause
Yeah,
it's always
sure.
the same number, that's
Yeah,
why, right?
yeah.
Cause it fully exists.
Mhm.
But then with the weak acid, you always do that here.
Yeah. Yeah, if you guys are able to do this well, like that would be good, but even if you're not, like, this was like last year, the learning from it. Even better for them, the students last.
Oh, yesterday, I searched up after and it was like K is equal to Ka reacted over K of colors.
Is that just always true?
Cause
Cause I was trying to
Pretty-
like, find a way to visualize.
Yeah, like that.
Never watched it.
It's because, of- yeah, you could think of it like that, cause.
It was like really long, visual, like,
I think
like, I heard it was a combo, but it was like,
there's an acid base on here.
yeah, but like, not that it was useless, but like, if you really understand it, about what's going for like functional.
So when you're like readily able to explain it, I do it. And that's why it forms that, and that's where it's something like that.
But how would you know that just from looking at this, that this is something, cause like K is not just products overreactants, cause then if it was products overreactants, that would be like this is, wait, is that what you meant?
Yeah, it's like reactants, there's so many reactants,
Yeah.
so that must be,
Oh, I
like, this
see.
is like readily reacting, so it's not very much in, these two because they're reacting. Or you use like, so the stable, like, yeah, that's the way I think about it, you could think of it like that, but that's, like, we didn't go for that, so.
Okay, that makes sense, cause I thought this whole term about like concentration as in strength, and I couldn't understand why that would be great, but that makes sense.
So like, it's just so reactive, right?
So if it's stronger, it'd be less of a concentration.
One thing you can think about it is like, it's like a ball going downhill, basically, right? Like, this is like up on top of the hill, right? And it's more stable, like it's more excited, basically. I mean, that's kind of fun.
Do you ever have negative pHs?
Yeah, you can. If you have like a highly concentrated like acid, you can have a pH less than 0.
Like on the test, you
Mm-hmm.
can show.
You can have a pH above 14 too.
Um,
Because like, let's say, find the negative log of, find the pH of like a point, like 5 molar barium hydroxide. And then like,
that makes you so uncomfortable.
I know, but it's gonna be like a pH that's
That
above
actually makes me
14.
like, yeah.
Yeah.
When it's talking about like silver, acid, they only are referring to like what the central atom would do, because technically couldn't like the lone pair on the oxygens like act as a base.
Yeah, like you could, I know that's like a little bit, um. Oh yeah, I was playing it the same yesterday, but they didn't really think that was something like this about. Yeah, you feel like, yeah, and like this is. Weird, and yeah, we're kind of counting for this one, but, yeah, like the center out and you know, we have. Like, oxidants, sometimes will be reactive, but like in this specific example, where they have water and so like. The oxygen isn't attaching itself to, like, what is oxygen gonna attach itself to the water? And hydroxide, it's not that, you have to like, it's like annoying, you have to like draw out the Lewis dot diagram, even us, like some very active too, which like. Yeah, a little bit a lot. Yeah, but like if you draw this, like the sulfuric acid, like, or the sulfate, right, so that's, you know, the formals attached to it, right, that oxygen can attach to the sulfate. Right, and so that's why we can also use it from the side diagram, the oxygen attaching to its attaching itself, the sulfur.
But we, like if the oxygen attached here, so the H would have to go on the oxygen, right?
Yeah, some. Yeah, that's a little bit of a kicker, yeah, that's why I'm like. No, but
Like generally, I just draw it like part of the.
how Mama got
this,
here?
And then just see if there's no comparison on the central one. then
Yeah.
That would work.
yeah,
Water would be a low space all the time, right? Cause it's has lone pairs.
I'm just hesitant because sometimes you feel like, it could, this could be like a one fluid acid in this case, so.
Thank you.
Like, let's say that if we an option, then they would have to. And it's also, I mean. I don't know. Oh,
Okay, I have a question whenever you're done. Like when you're done.
Yeah.
Like,
but yeah,
hello,
background, just think about it,
you done anything now? I
right,
don't know.
because you're not like, familiar with the way that reaction that you really should. But if you just know that it's like, well, hey, no, I'm still attaching yourself to it, like that. Indicates that it's not indicating that.
So you were locked for like other, like,
Yes.
it's fun.
Okay.
So you don't think about with electrons and atoms? You don't, like, when you think of it, you don't think of it with, like, if you electron, or lots of electrons, when you're
Yeah, just think of that, like, is there like one period or whatever on the central atom? Okay?
Yeah.
But, yeah, like, there might be a difference, probably more of, I guess, opposites, even times.
I mean, did they ever make something that's confusing to pick out the central atom?
No. No. They might give you like, the like, organic molecule, and then they might give you like, apple. What do you expect, the oxygen on there, it's apple, right? That might be a question, but like, if they're giving me like a straight up compound like sulfur dioxide, like, yeah, it has to be with, it needs to go, like, exactly, like, it wouldn't be hard to figure out. This. Alright, yeah, this is, I don't realize that.
So sorry, if you drew it out, like you said, and then like the oxygen on like this big compound has electrons, then you would say this is base. And he's like the oxygen specifically in like a big compound.
Yeah, 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 like if they ask specifically about the oxygen, then yeah.
Okay.
Yeah, that's like with the thing with like the theory, or like the, you go back, or you know, have one, my. The same nitrogen drive. Yeah, but not a whole molecule, something. That's it.
Me have a question too. Two questions actually. First, like, this one. Just like a memorization question, but like, I knew, because I thought that like for it to be a buffer, the numbers have to be like similar, opposite.
No, it's not about
Okay.
similar numbers, it's
So no
about,
matter what the numbers are, I don't look it up.
yeah, that's a red herring. You know, if it's a weak acid, conjugate base, or weak base, conjugate acid.
Should I be weak acid?
Yeah.
Never anything strong, right?
Never strong, nothing strong. So, right, conjugates are different by one hydrogen. So,
Yeah, it's the same thing as like this question.
Mhm, exactly.
Yeah, okay.
Yeah.
We'll put that one, so.
So which one's a buffer, right?
Well, it's not that, because these are like,
Strong, yeah.
that's weak, but. Not sure, but they're not conjugate.
Yeah.
They're just double acids. And then that's, you can't compare salt and a base.
Well, like Cl is a conjugate base of HCl, but HCl is such a strong acid. So it's
I mean, we have to know that, but
like HCl is a strong acid, like hydrochloric acid. So Cl minus is a very strong or very weak
conjugate
conjugate,
base.
right?
Oh, yeah.
Yeah.
But isn't this also a base? Is that
Yeah.
why? Because they're both bases?
Yeah, that's part of it. And also Cl is like a weird, like they're not conjugates either. So like,
Okay,
that's-
yeah. And then HCl, KOH, HCl. I don't know, anything.
so like.
That one loses that
They have a
passage. Oh, no, wait.
base, strong acid and a strong base, right? Is that components of the buffer?
Oh, wait, no,
Yeah.
yeah, KOH. I messed up my resume. Okay, so forest, and then, one more question, for Even like what, because I feel like everything I can like memorize, like I've tried to memorize them multiple times and I like forget. So if you like when it comes to pressure and volume, I know that they're like inverse.
Yeah.
I already know that. But
Yeah.
what is it, like, why, what is it and what happens and why about like the pressure and like a rule I've memorized, so, like it does move towards like more moles or less moles.
So when I like, let's say I'm squeezing like, hello, like let's say I'm squeezing things with that, like. You're gonna like you're gonna want the smallest amount like in your hand in order to continue squeezing, you know what I mean? Like instead of two, like. you
To keep
compare, like,
increasing pressure,
Yeah, if you increase
or
pressure,
decrease, or to go where it's less mole.
yeah, it's because you're gonna keep increasing pressure, right? So like I think about it, when I squeeze my hand, right, like the volume is increasing, like
Yeah.
increasing pressure.
Yeah.
And that causes there to be smaller little space in there, which means like the least gas.
What would that mean though for like the thing, because I get confused, like, I'm like, something happen, it's just like the opposite way, or is it like what, like?
So
Yeah,
like,
I'm concerned.
yeah, it's like, I mean, yeah, you could kind of memorize this, but. If you increase pressure, you're gonna favor the side with the least amount of moles.
Meaning to like shift that way.
Yeah.
So
And then if you increase it.
increase pressure shifts towards the side with.
Yeah,
Sorry.
gaseous moles. Like
Yeah,
gas
yeah.
moles, that's important.
You never count like aqueous,
Yeah, or solid or liquid or whatever.
is that for volume though? Do you
Yeah,
count,
volume is the same thing, right? So volume is
you
the.
count aqueous for volume?
Mhm.
Oh,
Yeah, so volume is like the opposite, right? So if you decrease volume, you're gonna favor the side with the least amount of gas.
decrease volume. I don't know, shifts towards side, yeah. More.
With least amount of gas. Least amount of gas, because the same.
Oh, yeah, wait,
Right.
please.
Like think about like cusping your hands, do it on the exam, you know, like. Right,
I'm gonna do this on the exam.
no, yeah, decrease like increase pressure, decrease volume.
Yeah, and decreasing volume because if you decrease the volume of like, is it like you're decreasing like of like the entire thing, right? So then, wait, oh yeah, I think that was my question, because that's really like the actual point of my question. What it says, like, you're, like, of the entire system, like, you're decreasing the other half, do you look at that side or that, like, what do you look at to like figure out? Do you know what I'm saying?
The
Like,
entire system, like it's like the whole like the vessel has like this equilibrium, right?
yeah,
So if you're decreasing the volume, right, it's not that, like you wanna see which side has the. Like,
gas,
yeah, which side has like the least amount of gas, right? So this side has 0 gas. This side has 1 gas mole. So that it's gonna favor this side, so it's gonna shift to the left. Because there's 0 gas mole here, and there's 1 gas mole here.
oh, so you just, if you see what happens, whether it increases or decreases, and then you count the amount of moles on each side.
Yeah. A
Right.
gaseous mole.
Gaseous moles.
Mhm. Yeah.
Okay,
Yeah.
gas, thank you.
Sam here, how are you? You got it.
Yeah.
Yeah. But and the same thing, but remember like the reaction, right? So K represents like the strength of the acid when it's like dissociated in the water, right? And so this reaction is showing the opposite, right? So it's showing how when ions react with hydronium, it's in both gases. So it's like the flip version. So this let's see what you get. In order to if like KACJ plus water, you have hydronium nine. Like if I flip it or you want over to A, I'm gonna get this one. Yeah, so, yeah, he didn't really explain this out because like, I think this is a question that we like did like last year too, but it was dealing with the translation. So whenever I do this question, regardless of the gases or whatever, right? one thing that I need to look at is like, how many, like, what's like the moles of say, and what's the moles of Pedro? Okay,
How tired?
so.
Right.
That's what's going on, like, this is and Pedro.
Also, you see, we're asking me questions that were like more than like you said, stuff long. Or like, or just like too complex, and I was like, please stop talking. And I kept telling this stuff. I just couldn't understand it.
So whenever you see that, I think that hydronium and then the rocket on the. Okay, that makes sense. Right, so now what I want to do, because we know, like, I know the first, we have a formula. Yeah. Yeah, so there's two hydroxide, so we're gonna do.
You have one more
Find the moles of
time.
bearing hydroxide, right? 21 times 21, which is 0.01, but then because it's 2, it's between 0 and 2. Right, that's the moles of hydroxide.
Looks
Because in
good,
the
yeah.
slide, that's also the moles of hydronium. Right, 0.0, right, so now if we take the moles of hydroxide or hydronium, right, and yeah, like you can plug it in the way that you did it here, right, where, or like. Where I'm usually like, you could do the same thing down here.
Is the other one the oldest thing?
No, this is going to be 0.3, right? So these two things, you want them, they use off the aspect. And the reason why I did that is like, we can figure out the moles and put acid, but we don't know how many, like, hydronium is used in this acid, right? So like, you can, like, like, for every like 1 mole that's acid, we don't know how many moles of hydronium. So like, if we have the moles of acid, we need to figure out the ratio of like the, like, for every 1 mole.
2 more hours. Man,
That's what it looks like that.
There's the-
Now,
Do that, means, psychology, or.
Yeah, but the psych exams next week are 1 mole. Like, I'm showing you this way.
I've never seen you
Like,
again.
straight down, shoot that like 10 to the box. Like, it's like not like on, all you have to do is find the moles of acid, and then the moles of hydronium or the moles of hydroxide. Just find those. But yeah, like, I know it kind of went through that a little bit long, but those kind of questions, like, they want to know how to do it. But just try to time to see. Yeah. Any other questions?
Okay, and I think that, like, I know that it's on the city,
A is not a conjugate, what they are, like, conjugates, right, are only different by 1 hydrogen. Right? That's just about 2. I thought I did.
Figure out the more negative.
But also from their buffers, right? If they ask the calculation point of the buffer, right? The difference is only 1 hydrogen.
I really agree.
So, and if you have to mark the most disaster. Yes. That's that.
Well, oh, sensitivity then, I can get this back together. Okay, next. When you're doing buffer problems, first of all, how do you approach them? I don't understand buffer problems.
Yeah.
The hint that a buffer problem is going to be there, that you have like a second thing being like a second weak base or strong weak acid being incorporated into the mixture, or what is the hint that there's a buffer?
So, the heads up, there's a buffer, if you have a weak acid and it's conjugate. That's like, a given.
Or we think some stuff.
Yeah. Like, you have to be able to identify, and this one, acetic acid, like, is a common one. But you should be able to identify that. And then, if you're asked, like, if you're adding like HCl, it's very similar to a titration. And that like,
Yeah.
you're basically adding a strong acid, so you have to do an ICF. And then after you do ICF, you'll have left over like
I see.
weak acid and its conjugate base, or like initial change in final.
Oh, okay, gotcha.
Yeah, and if you have like the base, if you have the acid and the base, right? You are, and you have the K value, you can do Henderson-Hasselhoff after that. So like after you do ICF is just like the sleep value. You're doing it because we want to figure out which side, like is HCl running off first or the base running off first, right? And so if the HCl is running off first, you're gonna have leftover base and leftover. Okay,
But then you have to repeat.
and so once you have leftover base over acid, you can take the volume because we added like there's now 1.1 bulk flow volume, and then plug it into like the now use the concentration. And then plug it like 1.1. And solve for that.
Like in birthday,
Okay.
1 liter of 5 molar of this, so they're equal, so that means like, that's an indication that pKa is going to be equal to pH.
Like, even throughout this, like, what would this?
Yeah, that is an indicator, like,
So then.
The fact that they're the same.
yeah, without HCl, yeah. PK goes PK, like times pH,
That concentration.
but yeah. But with this question specifically, like when you're adding HCl, like then that changes that, like so then you have to first figure out the change. And then you can.
Okay.
The ICF stuff there?
I did, but I didn't do it for this specific question, but like it's very similar to the titration, so like if you know how to do the titration, then you'll be able to.
That's like a super question. Just if the reaction doesn't mention, heat, if the reaction doesn't mention heat, how are we able to?
And then it's decided.
It does.
You know, it's so funny. I had the question like this the entire time, and this was over here. So I saw a chemical, and then I have to swipe, and it's not so endothermic. That means that it is positive, which means that it's going in, not being released. So
Yeah.
reactive,
Yeah.
meaning if it's on this side and heating at it there, then
Shift right.
it'll go up on this left, reactive side, and shift right. Yep. Yeah. Oh, so no. I know you're doing, okay.
Like there's a,
Everything's how I. I still don't.
I'm so like, I'm less interested now in this video, because I saw an hour 15, so I clicked off on this, I'm like, nope, not now, nope.
It's but no way. I think
Right,
it's
so I
worth
just,
your
I
time.
have to.
Yeah.
Okay.
I like it wasn't a hard watch. Like I didn't think it was bad. It was understood.
Right, because there's actually one of them.
Oh my god. I don't.
In the video, they touch on so you're. Stop watching it, go turn it off. This is not the time for that, okay? Alright, what's your call?
I'll find most of these, this is gonna be.
What's your call?
I want to watch this.
Turn it
One
down,
more,
turn it
one
down.
more.
Okay, like, we learned that like this comes off really quickly. but then-
Good luck on what? You're dead, how are you supposed to get any luck
So
on it?
because it's
Getting
getting off.
Let's talk about that
So
instead.
this number is.
Yeah.
First, hydrogen.
This is the most important thing to do.
Yeah, the thing is, like, so big action is like one example you make sure you know, but yeah, like, for this. What's that? Yeah, like, the first hydrogen is the strong acid, the second one is. So like, this will definitely be like 0.60, so like, that's why it's not like greater than 0.60. But it's not gonna be less than what's the.
Only its first association. Oh, then it's second one, it's not strong.
It's just, yeah, that second hydrogen is not something else, so you're not gonna get like 30 values.
The full association.
0.60.
Right.
How are you doing, bro?
Alright, so you've been able to learn most of it leading up to like, right?
19.
Shut up.
Basically, one choice. That's my favorite stuff source.
Yeah. Very good.
Yeah, so I have that video. That you can watch, because that'll help you out a lot. It's like an hour long. It has timestamps, so you can like go through whatever session you want. Like, questions or it's just. Like, other than that, I think I'm mostly paying attention to this, so. I'm really, a lot of this stuff.
And I felt really weird. And that's what most of those. And now, I only had secret.
Yeah, watch that video. And go and listen to, no, try to give buttons.
I have a question like whenever you're.
Yeah, yeah.
Yeah.
Did you guys send me
Oh, yes, yes. Okay, your point says this, so that's like. But as you associate, again, more.
I think you're so funny. Like it's just like the last piece of your makes me scared that I'm not even trembling, like getting closer and.
I'll show you. My thought, okay. When you add these, and this one will be.
Is it during times like this, you think Buddhist learning is the right choice?
Yeah.
Have the conversation here.
Yes, not trying to.
Switch there.
All right, and then liquids don't matter.
Okay.
Oh,
See if the almost every here, one second here.
okay.
Right.
Where was that?
You don't, yeah, don't tell us your.
Where am I?
Oh.
Yeah. Yeah.
I don't know if it was late last night or I found myself too long stupid, like, so I just like, it was getting so easy to, wait, what the frick? I just, like, trust my mind. It's the pay formation, it's more of six, yeah. Yeah, I had it. I just like don't get like, what's the equation for this? Like, I was trying to like, chat told me it's that.
Yeah, like a general formula for like, yeah, is I guess like a complex, right? Like a complex over.
The big thing is the complex.
Yeah, that's the big thing, is we're like a metal ion, and you could say it's like.
You made like half the growth.
Right? It's like, yes, the metal ion, and like, yeah, I'm sure that you can. Does
The
things
surrounding
like,
molecule.
yeah, so I can like.
So
So yeah, that's like. You don't even memorize it, like, it's just like, it's kind of intuitive, right?
You never know which way to put it. Like, where to put, 'cause sometimes like, it's all on the left side, and I don't think it's supposed to, but then I'm like, it does. But that's not what I have, the minus a plus X, and I'm like, wait, that's a plus X, why is it on the left side? And I never understand. But it's whether or not, and more product from Canada. So I just get so confused, I never know, I'm gonna end up messing up my question, because I flip the thing and then whatever I divide.
KG is when it's like.
So it's opposite.
So it's like, that's
I'm just memorizing one, yeah.
And the reason why like this is plus X and this is minus X is because there's already,
What's that good is?
because there's already like, there's already products, there's no reactive, but
But it's saying it was like a strong.
yeah, so there's a totally product.
Okay.
And then it has to subtract and stuff.
That's why I like, whenever I like am confused, I can't think of the actual examples that like, confuse me. Like, I feel like I end up understanding this because I wrote this, but like,
That's it.
like, there's sometimes where like, I just don't, because it's just like, it's not what it is. And then I mess up on the minus X and the plus X, and then like.
But yeah, this is like going back to like internet two, right? Like the products, right? Over reactants, there's zero here. So that means that the plastic shifts to the left. Right, initially. So that's why this is plus sign. It's like similar to like a weak acid,
Okay.
right?
So wherever it shifts to has the plus.
Yeah.
Whatever.
Yeah.
Alright. Try to do some of the questions like on my practice.
I am, but I just like remember. Yeah.
Then do that, it's the alcohol concentration takes 2 times out of it. So we would essentially measure the loss of things we lost.
I feel the energy, like a good energy. Maybe it's just like on that, or maybe on. Nah,
Number two, yeah, so.
like I.
But this is.
Like it's good for that.
Going over, first use of going over. So. I don't think. But anyways, like sulfuric acid is a strong acid, its first stage is going off, right? So that's why I did negative log of 42. That's like the negative of that first stage. And then, like, that second stage comes off not as a, right?
Yeah.
The Ka value, like we talked about in the past, is like, it's not like super weak, but it's like, right? It's 10 to negative 3 or something.
Okay.
Right, so when I did like negative log of 0.500, I like accounting for all of the hydronium that would be, if like hypothetically speaking, this whole thing associated. Right, and so that's 0.3, right, but the reality is not all of the hydronium is associated using like 500 molarity of hydronium. So because it's not fully dissociated.
You made it sound. like
You have to say that.
So does that mean that the positive energy came your way?
No, like that, I thought this was a question and I was like, how are we not giving any information about the KSP? But then I realized it's the KSP, it's right on top. And this is all one question, it's not just that, it's the whole thing. That's what I do as I recognize, I think this one. So laugh, it's the truth.
No, not laugh.
I suck at it.
Rest to laugh. At least right now.
Oh my god.
Writing down like I got it.
Is it the one with the largest? Is it the smallest?
If you do the negative log of this, if you do the negative log.
Yeah, buffers is,
Because.
I'm on page 2. Boom.
The negative log.
Why took you 45 minutes to one page? That's fine.
Yeah.
And there were multiple versus two. They were not like that.
and then they differ by Y plus. So, boy. Like they.
Yeah,
Wait for
Yeah,
that.
it is.
It's gonna work.
Exactly, right, it's up there, right?
Cause it's just like a word. We don't, 13 watts, because then HCLO would be explicit on the,
Yeah, so this will be.
so that would be the
So,
capacity and that would be. That's a con-
yeah, let's, so. One, like you guys will, right, I keep telling you, everyone's, right? The weaker the conjugate, the weaker the acid. The stronger the conjugate makes.
Oh,
Okay.
do you want me to make
As a
one right now?
The stronger the
Just see if you
acid,
can do it.
the weaker its conjugate makes.
So the weaker the stronger.
Yeah.
What is
It's still because it's a solid one.
The weaker the acid, the stronger the conjugate makes.
I don't know why I thought you just put words together.
The stronger the acid,
Solid words.
the conjugate makes, and it's the same thing with is it.
So this one here is.
So they're asking here, like,
We divided, make sure that every number is like K. So we divided 10 to the 4 by K. This one's the biggest number, the real question, no.
you guys didn't do.
I actually tried. Because I actually don't know anything about it, never mind. Okay, this one.
Like you didn't do. No, like.
But we don't have a figure, put it on high. So it's like.
You know what I recommend?
Yeah, that's, you guys
I
like this.
recommend
Yes, put the wrong.
You,
So moving in solid.
Like this
Solve
one
it right
right
now.
now, like
and do something that
this
this
top
top
one
one
is
is very appreciable. It's just to buy 2 Monster Energies.
Wait, what?
Oh, I'm getting. I'm down to some seats.
Yo, you're the one that.
Yeah, I know, I did tell you that.
Wait,
I did.
It's okay, it's okay.
Wait, okay, one more time?
It's okay.
Because of that, he probably the wrong place.
Guys,
And
that
then-
gotta be constructive.
Yo, wait, I'm so confused. What am I looking at? I flipped them.
Look, it's okay.
It's okay, it's
What the
okay.
fence for the
Yeah.
sustainability?
One thing like,
Bro.
yeah, one thing you have to like also
Yeah.
understand with this is.
So it doesn't even help, right?
To help myself out. Yeah, with the helps for you to say too, like. you have to know-
Yeah, well, there's nothing in here, man, there's literally.
Second time, dude.
Oh, like.
Yeah, like, every problem solved with the work, so we just find like reverse engineering.
Yeah, you're so good at it.
It was not.
Yeah, but even then.
I start missing some of those things,
Right,
the first one, you know,
4 minus 2,
I don't know how-
right, that's the reason
how
how
it happened.
and then the KV was part of that song, so that's why. Yeah.
I guarantee I fall into it, we're like different eye. Well, sorry, let's look at.
So I did it first and then I took this value and then. Negative one.
Yes.
Okay, negative one is since it's
Last year.
kind of another. I'm putting in.
There's
So I rolled with this for this.
Oh, it's like, it's first. We know we go in class, like, there's a video about how like acid. And the second hydrogen is not strong, so if you want to find the pH hypothetically, it's like both hydrogen. So instead of being slant, it's gonna be 0.500, right? And you do the negative one of that, you're gonna get.
1.00.
This is like suicide, really.
So that was very strong,
No, I'm not laughing.
and so that.
You're not, I'm not laughing.
That's not what's actually happening.
I'm so dead.
So it's gonna be about-
Don't understand that.
No, I'm not just.
Imagine. Like 2060 is only one hydrogen. And 2030 is only two hydrogens. The reality is in between, right? Yeah.
Like, quick question.
Yeah.
So, it's like, to find the H plus concentration, it's like 10 to the negative pH. So to find OH, it's OH minus concentration, it's equal to 10 to the negative.
Plus one times, the more. positive.
Yeah, but that's like 14 minus.
There's more, you know,
14 minus pH equals pH.
well, but yeah, for the.
So it's just 14 minus pH in the exponent.
Times higher, well, like.
Yeah.
We still see, we screw, oh, right, but.
So it comes up. What is it? 10 to negative 14 minus.
Why negative 14?
Because if that's how.
Wait.
EOH.
Negative
Yeah, 14.
14 minus.
Oh.
Yeah, if you wanna think of it like that.
So it's technically
It's like, that's the question you should ask.
14.
We have not.
Wow. Wow.
Yeah.
I don't know, why don't put a plus like that?
Oh, okay, so it's minus, so 14 minus negative. Wow.
Of hydrogen.
There's more than.
H, like a H plus,
Yeah.
yeah.
Oxygen nerd.
Yeah.
We're gonna see that because it's very.
Alright, you guys, I'm gonna bring us back together. Is there any specific questions you guys want me to go over regarding this exam for now? Or do you guys want like more time to just go through the exam? A little bit more time to go through the exam? Alright, I'll give you guys like, let's see, what time is it? I'll give you guys like maybe like 10 more minutes or so, and then we can go over some of the questions here on the exam. Okay?
I don't know how to apply this to this problem.
Like which?
I don't know if we're just being, I'm being slow, but I don't know.
So with this, right, you have to, so you can find the pH.
So
Right.
first we have to do is the pH and then find the POH and then plug pH into there.
Yeah, try that. I believe it. Anything down there, good?
I've got.
Watch. If you're like really like.
It's- Yeah, questions or anything?
Really based solely on paper. Nothing.
No, yeah, not specific.
It's like overall. And that's what it's like. And I get the space more. All the times that something. Yeah. So it's like, so I see like that.
You're adding, like, how do you think, right? So, like writing out, like the equation for like the acid and water. Right? Right? Like, we already have, like acetic acid here. You're adding sodium acid, you're adding the conjugate acid, or conjugate base, right, you're adding conjugate base. So you're increasing this product.
Yes.
So if you're increasing the product, you're gonna shift the reactions to the left. And now it's gonna use up the high growth then. So if you're decreasing the growth, yeah. So it's like based on what I said.
This is over here.
Yeah, like this is increasing that. Yeah.
Okay,
Mhm. Mhm.
thank you.
Yeah.
My answer isn't here. But this one looks close. Maybe I'm just being.
The negative log.
Yeah.
Oh, yeah, that's right. I don't know why it's like.
We just like, yeah, it's.
I know.
Which means that this is, that's not.
Or,
Think of it, if less than one is more reactive.
And so then.
Because it doesn't supposed to be, right?
oh, yeah, that's.
Two, one,
Yeah, it's
eight.
definitely could be rounded.
Yeah,
Yeah, definitely could be rounded, yeah. Yeah, this is like exactly what it's.
yeah.
It's easier.
This is my understanding.
It's less fun.
Yes.
When there's less product, this is stronger. Imagine this thing is so strong.
Initially, the solution had
Because they
1
cause
liter
it
of 5 molar acetic acid. Okay, so that acetic acid is our weak acid.
Mm-hmm.
So that means 1 liter multiplied 5 molarity.
Yeah.
5. So we have 5 moles of the weak acid, which in this case is CH3COOH.
Yeah.
Correct? Okay. Then it said there were also 1 liter of 5 molarity sodium acetate. Sodium acetate is just a salt, but when you add that salt in the water, it's going to dissociate into sodium and then acetate.
Mhm.
Acetate is the conjugate base,
Mhm.
so that it's not the salt that's the buffer. It's the fact that the salt breaks down into one of the things being acetate, and then that's the conjugate base. And then you have the weak base right here.
Yeah.
That makes buffer.
Yeah, so weak acid conjugate.
Okay.
So does that, right?
You just
expected
it.
Yeah, that's right, so it doesn't really.
Five moles of negative. Right, those are the two things that we got originally in the buffer solution. So now the new thing got added, which is HCl. HCl is a strong acid.
Mhm.
So strong acid can completely disassociate, right?
Mhm.
So it's gonna be HCl, then this is gonna completely disassociate to H plus and then Cl negative.
Yeah.
Cl negative doesn't really matter,
Yeah.
it's just a spec.
Yeah.
Okay, the important thing was this.
Mhm.
So then, you have 100 ml of 1 molarity HCl. So that means that 0.1 liters, multiply that by 1 molarity.
Mhm.
That means that you have 0.1 volts.
Yeah.
Of H plus. This H plus is now going to react with this over here,
Yes, with the base.
with the base.
Mhm, cause
Right.
acid reacts with base.
Yes, so the H plus was our acid, right? That'll react over here. So I have these two. The CH3CO negative plus the H plus, that will form this,
Mhm.
more of this, CH3CO, right? Okay, so I increase the amount of CH3COH, this the weak acid, I increase that, so from 5 moles plus 0.1. So that makes 5.1 moles
Mhm.
of CH3COOH. And then this also means that since you used up some of this will go down. This will go down by 0.1 moles.
Mhm.
Okay, so 5 moles minus 0.1 is equal to 4.9 moles.
Mhm.
CH3CO. So the conjugate, we have the weak acid and the conjugate base.
Right.
Next, I can put this into the Henderson-Hodgkin-Bosch equation.
Yes.
So it plus, or is it minus? It should be plus, right?
Yeah.
Plus the log of the conjugate base
Yeah.
and the weak acid.
Yeah.
There.
Mhm.
Okay, now I just have to convert this instead of moles to concentration. And when I do that, then the answer will give like something like 4.7.
Yeah.
So I went through this whole spiel to ask questions because I didn't really know how to present my questions without going through this process.
Mhm.
First thing is, why is it that in this case, the hydrogens will all react with acetate? Because I could do like CH3COOH plus H2O liquid. This will then, we say like it could go forward or back, and then it'll make H3 plus CH3.
Right.
So why is it all the hydrogens, 100% of them are gonna react with acetate?
It's because that this hydronium
How is that
is a strong acid. So like there's when we just have a weak acid on
Was
the
this
salt,
based on like the?
it's producing a very
the
negligible
amount
amount of hydronium.
Each side?
In the sense of that,
So
like
like,
it's like
you're gonna look at.
it's not going to like produce this much
Which side?
reactants are they use. Like there's
Reactant, yeah, sure.
there's not enough
Acid,
like the hydronium
It's gonna
concentration is like not significant enough to shift the reaction.
And with pressure, it's like.
Okay, yes,
But
because
there's
the
more pressure.
Ka
K is like very
value
low.
is yes, small,
Yeah,
And then
it's like
there's
1.5. Right, or
gotcha.
like
Yeah, something like that.
like when
So
you have a
like-
strong acid
Less volume.
reacting with the like putting into a buffer, so it's going to react fully with the conjugate.
So less moles, but it.
How do we know that? Is this
Like,
just a rule that?
Basically,
everyone
imagine
should
like
raise
I
from
took my
council?
water, right?
But this is
Imagine
also,
like all the
that was
water,
like
like,
right
imagine-
there.
Yeah.
What's the difference between the H plus there
And
and
I
H
put
three?
like.
The difference is that there's not a significant amount, this is gonna be in equilibrium,
Uh-huh.
there's not like anything being added,
Yeah.
Okay.
right?
So
So
that
like,
means that you have to, so that means that you're gonna have to. put
yeah, like there's
everything into
a
this.
very,
That's like, that's like.
in comparison to this, there's a very insignificant amount.
It's like.
Okay,
imagine,
so
like,
before it was
like,
only
you don't
like,
have
it just
to- it's like
increased a little bit,
yeah.
when we broke the CH3
Yeah.
into
because
the.
like-
Then you added
think
the
about that,
0.1 moles,
Yeah.
so this made it so much,
You wanna-
that then you have to
wanna
apply
condense
the
everything
like,
up. So
years
you
per
want
Yeah.
less gas.
and then the reaction will
But
reverse
the
that.
other thing which is kind of important, right, you don't have
more
that
space.
significant
So
amount
now
of,
all like that,
like,
that other stuff.
we can
That they have
copy,
out.
right? Like this would have both of
all
them.
that white.
Equal quantities.
Yeah,
Okay, so if your
Very,
pressure increases.
success, like,
space, you
If
want-
you were to just add like hydronium to this reaction, just
Your pressure
5 moles of
increases,
acetic
yeah.
acid,
mm-hmm,
like
Basically,
it's not going
like,
to,
So.
like, this
You can
amount
just
would
take the- if it's more
completely
pressure,
react
it's
fully
more
with this,
container.
and then you'd be
You
left
can
over
just
with
take
excess.
small
hydronium.
container and you once-
sorry, repeat that.
Yeah.
I
Like,
lost-
remember how
Okay,
like
so there'd be.
this is like
The other side has more
insignificant
gas.
amount,
has
Yeah.
less
So if
gas.
you're added this amount. to
Not
this,
this gas.
Right,
This gas
it's gonna react fully with
It's
this.
side, with it,
And there's
yeah,
only
it's the
excess
direction
hydro.
of reaction going.
Yes, whatever amount
Yeah.
from the
Yeah.
breaking of this.
Yeah.
Okay.
So, yeah, like,
And then you.
that's why we don't write those reactions out,
Heat as like a reaction.
because like, that's not what's happening, right? What's happening is if we have this base, and this also, and it's the buffer, it's not, the base will react with the hydronium coming in,
Yeah.
the acid will react
Heat
with
is a product.
hydroxide.
So it was all.
And the reason why it's a buffer is because at the end of it, you're gonna replenish one of these, right, or somehow, like, either this is gonna increase and this is gonna decrease, like this is gonna increase. and this is gonna-
Okay.
So, yeah, like,
Gotcha.
your thought process is really good. I would say like, what's important is trying to do the ICF,
Uh-huh.
just because like, it'll help make the work a little bit more, like, I guess like faster to
Okay.
do.
So I don't know, I see if I'm guessing you explained that on your video.
Yeah, I explained that in a bit,
Gotcha.
but yeah.
Alright.
Full
So
calcium.
a buffer is not a single molecule. A buffer is a mix.
So you,
Two things.
conjugate acid and weak base, or weak
Or
acid.
weak acid.
conjugate.
The role is that regardless of how much
Just add it on over here.
hydronium or hydroxide ions you put in,
Yeah.
it'll always net
Yeah.
out, like in this case, they equal
Bromine
10,
is gonna be
right?
like
5 + 5 will.
Yeah, but it's not always like.
Oh, calcium.
Oh, okay, they
Yeah.
can change.
Yeah, they can be different, right?
Okay,
And
and it could still be a buffer.
yeah, the concentration doesn't matter, it's just, like, do we have this and this, like, in the same thing?
Okay.
One thing I would like to also know is like, yeah, the hydronium is gonna react with this. We had hydroxide, it's gonna react with the acid, and it's gonna do the same thing, because it's just like the acetate.
Yeah.
You have more.
Okay, but yeah, try to go through the video, because the titration video, my questions are very similar to this.
Okay.
And then so this one, I can go around. It's just like this, like.
I like so stupid. I don't know why I'm like, I don't get this.
So the difference.
Just what it is.
The difference is that. So basically like, which one has or one solid, like in your.
Yeah.
It,
Literally just be.
but it's asking for
Yeah, so,
the,
yeah,
as a conjugate acid, right? So conjugate acid means that it has an extra, like,
Making that.
So this is the basis.
Yeah.
Can be something with like.
yeah, so like, we need to know,
I thought acids have like
Oh.
less
basically,
hydrogen
you
because
have
they
to
don't need.
find the.
well, like, if we're like to do like a reaction, right, like, if this was like in a reaction with like a base, and we're asking for like, if this was acting as a base in a reaction, and we're asking, like, for the conjugate acid, right? That means that the conjugate acid on the other side has to have that,
That's
right?
why you can do
Like,
like.
that's always like been a rule.
And if it's
Like,
not.
when you think about water, like, water is a base, what's the conjugate acid of water?
Yeah.
I think it's hydronium.
So this is trying to actual hydrogen in the
Yeah.
bar.
Same,
And then get the pH.
Okay.
and then-
so all you have to do is figure out which one has an extra hydrogen.
Then you go,
Yeah.
then what you do, is you have to do T minus like the pH value. Then you take that number, so for example, right, let's say like this was like 3, right? Then you would
Six.
do 10 to whatever hour, that's.
What are we like using?
So-
Yeah.
That's strong, meaning
Yeah,
it's only
yeah.
used for you to see this.
So I want to calculate what are the moles of hydronium, at least from MCl, and that mole of hydronium is going to equal the moles of hydroxide. And then from there, you can work with the groups to figure out the volume. If you have the molarity of the magnesium hydroxide, or one mole of magnesium hydroxide, there's 2 moles of hydroxide.
Not that exact, so you can
Figure out from 1/5 of magnesium hydroxide, there's 2 moles of hydroxide. You see
Oh,
the-
because of that.
Yeah, yeah.
Yeah.
So you can work backwards. Like, I'll go over that question because that's very important.
What do you?
I'm gonna go over it like now.
Yeah.
All right, guys, I'm gonna bring you guys back. All right. I'm gonna go over a very important question because you're definitely gonna see a question like this on your exam. And I don't really think he went over it that much. It's not like a super long question, but let's go over to 17 on the practice exam. All right, this is just a neutralization question. All right, neutralization, we did this last semester. And so we're gonna be doing some things that we did last semester, but it's very important that you guys are familiar with how to do this because it's not that hard of a question. You just have to be aware of like what's going on. It could take like, really, it shouldn't take more than like a minute to really solve this. So let's try to do this out, right? So whenever you see a neutralization question, immediately you want to think this rule, right? At neutralization, oh my goodness, that's thick. 1 second. Why is that so thick? Go back. At neutralization, the H plus ions equal the hydroxide ions, right? This is the same thing as the equivalence point, right? At the equivalence point, the acid and the base equal one another. Okay? Are you guys good with that? So that's like a rule. At neutralize, like anytime you see neutralize, H plus has to equal hydroxide. So now they're asking here, let's find the volume that is required to like of this base to neutralize that amount of acid. And so what we can do here is we can solve and find the hydronium like moles or concentration. Yeah, you can find the hydronium moles of 17 or of HCl. I should have specified this. I actually, not that the concentrations are equal. The concentrations are equal, but it's actually more so that the moles are equal. So the moles of H plus and the moles of hydroxide are equal. Okay? That's like the definitive rule, okay? The moles of both of those things are equal. So when I do this question, right, I'm going to find the moles of hydronium. So let's do that, right? We got 0.0100 molarity of HCl times 1.5. And that's going to equal, what is that going to equal? That's not really that hard. 1.5. I'm just going to calculate it. 1 second. Just let me get to the calculator. 0.01 times 1.5, right? All right, okay. 0.015 mole of H plus. Okay? Right? That makes sense, right? The reason why I decided to choose HCl is because we have enough information to solve that, right? We have the volume, we have the molarity, and we have the formula for HCl. So we know that there's only one H plus. And so that is this will equal the moles of hydronium. Okay? What this also equals is the moles of hydroxide, right? So we can say that there's going to be 0.015 moles of OH minus because that is enough, like that's how you neutralize it, right? You have to have equal amounts of hydronium and equal amounts of hydroxide. All right? Everyone good with that? So now we need to work backwards. So for this molecule, magnesium hydroxide, for every 1 mole of magnesium hydroxide, there's 2 moles of hydroxide. Do you see that? Does everyone see that? Right? So what we can do is we can create like a little ratio, right? For every 2 moles of hydroxide, there's 1 mole of MgOH2. Okay? This is like going back to what we learned in Gen Chem 1 with stoichiometry. The reason why this works is because, right, we have moles of hydroxide, right? Those are going to cancel out with the moles of hydroxide, and we're going to be left with magnesium hydroxide. And then from there, we can use the molarity. So we have 0.250 moles of molarity of magnesium hydroxide. Do you guys remember what the units for molarity is? It's moles over liters, right? So you can do like 0.250 moles over or under like 1 liter. And that's going to give you the volume. Okay? So like to recap what I just did there, right? I solved the hydronium concentration first because we had enough information to solve that. And then from the hydronium concentration, that's the same amount that of hydroxide moles that you have, right? And from the hydroxide moles, I worked backwards to end up at the like volume, right? If you cancel out all the units, you're gonna now have just volume left over. Okay? And so the answer in this case, let's see. So 0.015 divided by 1 over 2 divided by 1 over 0.25. I got a value of 0.03 liters or 30 ml. Okay? Is there any questions regarding this? Okay? I know there probably is like some kind of formula for this. Like if you look it up, you could figure out some acid-base neutralization formula. I'm sure there is something like that and it's probably reliable. This is like reliable to me because I forget that formula all the time. That's why I just always think about like, oh yeah, H plus and hydroxide, they equal one another in a neutralization question. And so if I know that they're equal one another, I can convert both of those and figure out the other, depending on what we're trying to figure out. But there's definitely gonna be a question like this on your exam, and we did not go over it like that deeply in class. That's why I'm gonna go over it here.
What is your?
30 ml, sorry.
Oh.
That's my bad. My handwriting is bad. Okay. All right. Any other, like, is there any specific question that you guys would like me to go over here? Um,
My eyes are actually closing. I don't know if you could tell. Like they are actually like.
That's right, because you slept for such a short amount of time.
I still have to do the active chem homework as well.
Mm.
So tough.
All right, let's go over 23. 23 is important. I made like a mistake. This is supposed to be acid, but it doesn't really change that much, but yeah. So we have this structure here, and it's asking us to figure out what kind of acid base is it. Is it a Lewis base, Bontelleri acid, right? Or whatever, right? And so when you look at the structure, it's really important to recognize the nitrogen there, right? It's very similar to the ammonia that we've been talking about. Ammonia, right, we talked about, has that lone pair on it. So like an example we did in class, right? You want to make sure you're familiar with writing out the Lewis dot diagrams for things, because it's very important for when you guys are like deciding if something's a Lewis acid and base or whatever. So like this nitrogen is very similar to this, and that has that lone pair. And so that lone pair can act as a Lewis base, and it also can act as a Bronsted base, because that lone pair can accept a hydrogen, right? And so yeah, that's why the answer in this case would be E. Okay, even though there's hydrogens connected to the carbon like this, it's not really going to donate that hydrogen, because that's not really an example we saw in class where a carbon directly attached to hydrogen will be donated like that. But yeah. All right. Is there any specific question you guys want me to go over here? Like, this is your time. This is your time for me to go over like the hardest question here or whatever. Let me look through it and let me see. All right, let's go over 24 and 25. All right, let me just quick. So with 24 and 25, it's very similar. Like Professor Yusa said, you're gonna have a question asking about the titration curve, and you're gonna have to identify what's happening. Strong acid, strong base, strong acid, weak acid, weak base, or weak base and strong acid, right? Weak base, yes, weak base, strong acid, right? And so in this question, right, we see that the titrant in this case is going to be NaOH, right? Or sorry, I'm kind of jumping the gun, right? We see that we're starting off with an acid, right? That's why the pH is less than 7. And another takeaway is that we see that there's an equivalence point that's 8.75. And if you guys have been, studying hard, right? We know that in a weak acid, strong base titration, the pH at that equivalent point is going to be something greater than 7. So the pH is greater than 7, right? And so what we see here is this is going to be a weak acid, strong base titration.
So when we look at this, the only example that matches that would be choice C. All right.
One little like vocabulary word that I would like to go off of is titrant. Titrant is the thing that's dripping into the Erlenmeyer flask. So like with acetic acid titrated with sodium hydroxide is the titrant dripping into the Erlenmeyer flask, which has the acetic acid. Okay? So this is like an example of a question that you could ask regarding that graph, right? He's gonna ask a question. He said that a couple days ago, so that's really important.
With question 25 now, we're gonna be asked like what indicator is very important for finding that equivalence point. And so we're gonna be given like a bunch of indicators here. Oh, 1 second, sorry. We'll go back down. No, stop. Okay. Yeah, we have all these indicators and they usually will give us like a Ka value. And so they're gonna be asking like, what's the most appropriate one? My strong advice would just be to do the negative log of these Ka values. Because pH is equal to pKa. Yeah, I don't really fully understand why that works out, but if you just do the negative log of these Ka values, you'll get a pH value, and whichever one pH value is close to that 8.75 will give you the right answer. I personally, yeah, I don't fully like understand the logic behind that, but I just understand like that's what you would have to do here. You didn't really go over that in class as well, but again, this was a last year's exam, so you had a question like that, and people were like, "Huh," right? But you guys won't be like that because we're going over it right now. Okay, so let's do that. Where is it? So if I do the negative log of 7.9 times 10 to the negative thing, right? 7.9 times 10 to the negative 5. All right, this is 4.10. Here it's going to be negative log of 3.2 times 10. Oh, 1 second, sorry. 10 to the negative 2, which is 1.49. Here is negative log, right? 1.7 times 10 to the negative 4, 3.77. All right, I'm just gonna keep doing this until I get a value that's close to the equivalence point. Negative 10. 1 second, sorry. Negative log of 2.8 times 10 to the negative 9. All right, so I got 9.20, and then this is 8.55, right? And we see here that this equivalence point is 8.75. So you would want an indicator that will start indicating very close to that equivalence point. And so 8.55 is the closest one, and so that's why E is the right answer. Okay? Yeah. All right. Are there any questions about any of that? All right. I went over the niche kind of questions that you could ask. All right. Yeah, like those are like the questions we didn't really talk that much in class about, but it was pretty much on the exam there.
Thank you so much for enlightening me on chemistry. I'm very grateful. Bye.
All right. Anyways, is there any other questions regarding this?
You guys want me in? Let's see. Is there any other questions? 10? All right, let's do 10. Good question, right? So we're dealing with Le-Chatelier's principles here. And 10 is asking calcium bromide being. And calcium bromide is actually soluble, right? So CaBr2, right? It's actually soluble. So when you add it into a liquid form or like a liquid like water or whatever, it's going to dissociate and it's going to produce Ca plus 2 plus 2Br minus.
Now, why that's important
is in the reactant side, we have calcium chloride, right? And it's also an aqueous. And so it actually is Ca plus 2 Cl minus, right? And so if we're increasing the calcium plus 2 ions, we're going to be increasing the calcium plus 2 in the reactants. And so because you're increasing something in the reactants, you're going to shift the reaction to the forward, right? Forward reaction. So this is going to shift right. So the answer here would be B. Okay? Is there any questions regarding that? All right? Any other questions? Anything? Yeah, if you guys notice, he didn't really ask like 4 titration questions. Like he asked like probably like 1 titration question in this whole thing. So it's like a lot of concepts. Hmm. Let me think. All right, let's try to do 29, I guess, right? 29 is actually 29 is a strong acid, strong base titration. We don't have to do that. Okay, let's try to do 30. All right. 30 is, we see here, like what is the pH of an aqueous solution with potassium iodate and iodic acid, right? So, and they give you a Ka value that shows that it's slightly weak, right? And so whenever you see you have a weak acid and you have its conjugate base and you have a Ka value, you do Henderson-Hasselbalch, all right? So this question here is very, like, you're definitely going to see a question like this on your exam, right? pH equals pKa plus log base over acid, and you just plug in. So it's going to be negative log of 1.70 times 10 to the negative 1 plus log of base, right? In this case, it's 0.0225 over 0.0150. All right? And then you solve. Okay. So let me do that. It's negative log of 1.70 times 10 to the negative 1 plus log of 0.0225 divided by 0.0150. And yeah, I got a value of B, choice B, 0.95. Okay, so like this question shouldn't take that long, okay? This question, weak base, you identify you have a conjugate, like a buffer, all right? And you have the K value, Henderson-Hasselbalch, all right? Make sure you do that. I prefer like underlining things so I understand what's going on. If that helps you, that's really good. Because yeah, that like saves me time to really figure things out after I read it. Like I figure it out as I read it. Yeah. And then 31 is like a titration question. You guys want me to go over 31?
Sure.
Okay. So 31 is going off of this reaction. So like, what is the pH of the 2-liter solution if I add KOH with this amount? So this is how you do the titration, all right? Sean Beer, pay attention, okay? Okay. So with this, right, we see we're adding KOH, so that's a strong base. So we're gonna react that with the acid, which is HiO3. So I like to write out the reaction first. KOH, right? And so what we're gonna produce, water and KiO3. All right? And so we're gonna do an ICF chart with this. I stands for initial moles. So we're gonna have to solve for the moles of this, right? So with iodic acid, it's 0.0150 molarity times 2. So that's 0.03 moles of IO3 or HiO3. The like the iodate, right, is 0.0225 molarity times 2 liters. So that will be 0.045 mole of IO3. And then the bottom one, KOH, is going to be 0.0150 m times 0.1 liters. And that's going to equal 0.00150 moles of KOH. Oh, yikes, sorry. Go back down. KOH. Okay, so I found out all the moles. And so now let me just plug these moles in, right? So we got KOH, which is 0.00150, right? HiO3 is 0.03. And then IO3 here is 0.0450 mole. Okay? And so we see here KOH is running out, right? And so that's going to be the thing that's limiting, right? That's the thing that's going to run out. So we're going to subtract the reactants by KOH. So there's that amount, 0.00150. And then here, it's going to be plus 0.00150, right? And so let's add these things out, right? 0.03 minus 0.0150, right? 0.015. All right, no, I did not do that right. How do we do that? Is it gonna be right? 0.285 mole. This is 0. And then this is going to be 0.0450 plus 0.00150, 0.0465 mole. Okay? So after we do the ICF, we have the moles of acid and base. And we need to figure out the concentration. So this is 100 ml plus 2 liters. So that's 2.1 liters. So we can divide both of these moles by 2.1 liters. That's, yeah, 1 liter. So let's do that. 0.0285 divided by 2.1. And 0.0465 divided by 2.1. All right. So I got like some values for this, like this one is 0.0136, like approximately this is 0.0221. I would recommend you just do it like exactly from the calculator. I'm just writing it out for you guys. And then now we can do the Henderson-Hasselbalch, right? We have the Ka value from the previous question, and we have the moles or the concentrations of both acid and base. So pH equals pKa plus log of base over acid. So that base in this case is IO3. So 0.0221, and the acid is 0.0136. So let's do that, negative log, and then the Ka value is, what's it called? 1.70 times 10 to the negative 1. And that's from the question over here on the top left. So if I plug all these things in, 1.70, 10 to the negative 1, plus log of base. So I'm just plugging in the exact numbers on my calculator. All right. What's it called? Did I do something wrong? What did I do?
On the left-hand side, aren't you decreasing the volume to make the correct reaction proceed? So it would be like 1.9 liters on the left-hand side. For HiO3.
No, the total volume though. You're not decreasing volume for HiO3.
Okay.
Let me see something. What did it happen to?
On your enter key, you changed the concentration to 0.150. Like,
Ah, 0.150 for KOH. That's why. Oh, okay. So everything changes. Great. So, oh, okay. That's silly. Okay. All right. My bad, guys. So then this is gonna be 0.15. That makes things a lot easier, actually. This is gonna be 0.015. This still cancels out. And then this is going to be 0.015, and then this is gonna be 0.0600 like that. And then you divide these out. All right, does everyone understand what I just did there, right? On the answer key, I made an error on the practice exam where instead of it's being 0.0150, it's supposed to be 0.150. Because none of the answer choices would correlate if it was 0.0150. And so now we can figure out this thing, right? So 0.015 divided by 2.1. Okay, and then 0.06 divided by 2.1. Okay, and then the negative log of 1.7 times 10 to the negative 1 plus log of base. So this is the base over masses. Okay, all right. So let me plug these values in, right? So this is going to be like 0.0286. This is going to be 0.00714-ish, right? I'm going to plug in the exact values and I got 1.37. All right. So this is moles. This is also moles. Okay. Yeah, because everyone, I know it kind of like, that was a little rocky. Are there any questions about this? Any questions about this? You guys chilling with this? Yeah.
What ratio is the same, you just divide by moles? Do you have to divide by volume?
Like if, like, let's say that this is the same mold as this.
No, like you would still get the same answer when you divide, when you do it without dividing by volume, because the ratio is the same.
Well, no, they wouldn't be the same. If you don't, like, this is 0.06 and then this is 0.015. Like if you divide both of these, like the ratio changes slightly. Still divide out the volume, okay? That like the formula has concentration in it, right? So that might be true. I don't think it's true because if it was true, the formula would be moles instead of concentration. So yeah, just do the total volume. Okay? But yeah. Any other questions? You guys have any questions in the back about this or anything?
Yeah, when you're doing like the Hermitian Hassel equation, you have to use the pKa, right? And then the concentration. Don't you like get the pKa?
Yeah, the pKa was given in this question before it, right? So 30 and 31 are like the same, like in the same question set. The first Ka value was given in 30, and then it says from the previous question, right? Like, what's the like pH, right? So we use the Ka value from there. Yeah. Yeah. Any other questions? Anything? Okay, this is probably like the question he expects people to spend 10 minutes on, right? If you guys know how to do this question fast and properly, it shouldn't take more than 5 minutes, maybe.
Where did you obtain values for the conjugate base and the acid?
The conjugate base and the acid, I obtained those values from the previous question as well. So like the previous question gave you the molarity of the like potassium.
Like to get the negative log of 0.0286 divided by 0.007.
Wait, negative log of which one? Where?
Like get the bottommost equation, the Henderson-Hasselbalch equation.
Mhm.
The bottommost one.
This one?
pH is equal to pKa plus,
Yeah.
yeah, those two values. That's
I divided out the new ones. So like the new moles over this is equal to this value.
The new,
So here, let me get there. Like this value, I didn't write this out because I was kind of rushing a bit, but here is going to equal 0.0. And then here is going to equal 0.0286. Yeah. Yeah, and KOH here is going to be 0.015, and that's why this is gone, like this runs out. And that's why we still like subtract there 0.015. Over here it's plus 0.015. Okay? Yeah. Yeah, let me know if you guys have questions, okay? All right, I'm still free to answer emails, do whatever. And yeah, I'll try. I know you guys have psych tomorrow for some of you, but I'll try to be here around 8 o'clock if you guys have questions or anything. I might be sleeping here on the bench outside, but it's okay. I'll be here for you guys. If you guys have any last minute questions or anything. Okie dokie. Okay, all right. I guess I'm gonna end the session here. Yeah, I'm gonna post this video as well. I didn't really go over everything, but that's okay.